Greetings, everybody, and welcome to my presentation for the Doubly Linked List in accordance to the class that I'm taking at the University of Advancing Technology. And the class is called CSC-382, and that is all about data structures and algorithms. And let me tell you, this class is not for the faint at heart. This is my second attempt at this, but I got it right this time. I got everything that the professor requires, and I'm happy, and so is my bird. So let's get involved in this right away. So here's the thing. When I first did this linked list, this doubly linked list that I was supposed to do, I did it procedurally, which means that I didn't use classes and it wasn't object oriented. And well, it was basically a test bed to see if my program would actually run. It did, but I noticed that redoing it, I had to think outside the box a little bit, especially when it comes to the C++ file for the class itself. We're using templates, and a C++ file isn't going to work in the end with the template. You have to convert it into a header file. Um, and thanks to my professor, I was able to do that with ease. Not a problem. Okay, so let's dive into this, shall we? Okay, so for time constraints, I used the namespace standard to make sure that I didn't have to type in the extra stuff. I like doing that. Maybe it's not professional, but what's more professional? Saving time and money for the company, or having to type everything out by hand. Let's think about things here, right? Anyway, so moving on. Just getting into it. Main function. I have a class called linked list. It is a template, so I have to declare the type when I am basically instantiating one of the objects in the list. So I do that and I call it list. And I apologize, my bird is being really rude right now, but I can't do anything about that, unfortunately. So anyway, here we go. I insert a couple of numbers, uh, 12, 7, 21, 42, and 88. I do this in random areas. So I use different parts of the program, of the class. I use the different functions. You see a couple here: push, append, insert after. And then I basically print the list starting at the head. And then I basically have a find node function that is going to find a number that you want. We have to specify it. And I looked for number 7, and it's in there. And then one of the things we're supposed to do is to add a value at the end of the list. I have a function for that, and it inserts 220, and it does it good. And then I have a function that can delete a node. This can actually delete anywhere in the list. I decided to delete node 7 to show that we can delete something in the middle of the list. If I have to, I can delete one from the front or the back. If you check out the code, you will see that that is true. So getting into that, let's get into the code. Here's the original header file for it. Now you can see that I'm using templates. Templates is new to me, and it took me a while to grasp, but now that I got it, I think I'm going to use this a lot because it basically makes your class generic or your program generic. And if you're using data structures, it's important because I can take this code and modify it for anything that I want now. Integers, strings, different types of variables. And I like that. So the one caveat I do not like, and this is just a preference, and my professor might disagree with me, and he has every right to, and he has a legitimate reason to. But I was told to make the this node here a class and use it as an object. Now I can see that, we can use an object in an object and stuff like that. And I suppose it's true to do that way because, in a sense, we are instantiating an object within an object. So I can see the logic behind that. But to me, it's easier to make it a struct. I don't get to use structs a lot. I like them, so I really wanted to use a structure, but I refrained and used the class, and it worked good. It worked perfectly. My professor was right about that. So you learn something new every day, and it was well worth it. Picking this guy's brain has helped me out a lot in coding. So again, my class here is called Linked List. It's basically the only true class that is in this header file. Um, Compared to the node class, which, like I said before, is something that it's a give and take with me. But anyway, so here we go. So it is a linked list, and in that I have a bunch of functions. Push function, I have an insert after function, and a append function, which is really neat because it basically appends stuff where it's at. Pretty cool. I actually found that online and decided to reverse engineer it and then use it in my code. And I'm glad I did because I learned a lot about this. So did my bird. Anyway, so we print the list, we find a node, we insert at the end of the node, and we delete a node. And this would be the C++ file that accompanies the header file, but because we are using templates, I have to actually trick it into being another header file. So, and actually, I'm not sure if I really needed to put that there, but I'm going to keep it there. It works anyway. Professor, you can let me know if that's needed. I appreciate it. Okay, anyway, so look at this. This code is brilliant. I love it. I really took my time with this and had to do some research. I don't think I could have did this without doing the research, to be honest with you. This is a brand new way of coding for me. I'm used to coding text adventures in video games and simple programs, and this was a raising of the bar here. I'm really happy with it, to say the least. So this push node is basically it's going to make a new node and it's going to push it into the linked list, the doubly linked list, and kind of make it the next one in the node. So that's kind of what that does. Now insert after. Well, I'm sorry. No, yes and no. I can, but I use it actually to instantiate the first node. Very tricky. Caught myself. Okay, so anyway, this insert after, that is the one that inserts after the node. It puts it in the previous node. And then append, well, yeah, you can append this node. And this is something cool that I'll show you. It'll append it at the end. All right, so this one here, we print the list. It's pretty much straightforward. Print a list. And then this one is pretty cool because we can do it forward or backward with just a few lines of code. I thought that was pretty neat. Finding a node, I was supposed to find a node in it. This was pretty easy. It's self-explanatory, really. You got two if statements. If the node equals null, well, the data doesn't exist. If it's not null, then we found it. Insert at the end. This was kind of tricky. You have to basically make sure that you're inserting at the end that if it is not null, then you have to keep going to the next one. That tripped me out a little bit because when I tried to put it in, I was getting an error, and I realized that the program wasn't searching to see if it was the last one. So this is going to keep going. It's going to loop through the list until it is null. And then once it is null, it's going to insert it. So the delete node, this is kind of cool. So it can be modified to delete anywhere, really. If you look at it, if the node is previous, if the node previous in the previous version is not equal to null, then we go to the next. And if it is next is not null, all the way to the end, we go to the previous. And then we find the number that we want to delete and we free that node. And I'll show you how that works here. So deleting node, we delete node 7 by telling it to go to the head. Here is my program in action. It's been a long day for me, guys, so I'm going to try to make this brief. Okay, so it works. So we create a DLL, it puts the numbers in, then I traverse in the forward direction, and here are the nodes. Then I traverse in the reverse direction, and here are the nodes. I search for the value of 7, it was found. I add a value of 220 to the end of the list. We do that, and then we traverse in the forward direction, and you can see that at the end of the list, in fact, there's a 220. Then I reverse it and put 220 at the beginning of the list. Then I delete the node 7. All right, and then traverse in the forward direction, and obviously 7 is gone, and then we traverse in the reverse direction, 7 is still gone. That is the program. Thank you very much. Have a wonderful day.